H3BO3 is what? H3BO3 is what? It is also known as a hydrogen hydrogen borate. Okay, it is also known as hydrogen borate. If you take its structure first, then you can easily answer this question. See, it is boron have incomplete octet. Here boron is having incomplete octet, so that it is able to accept, if it is react with water, suppose just imagine if it react with water, in water which ions are there? OH minus along with H plus ions are there, so that it can able to accept lone pair of electrons present in the OH minus ion, so that by accepting these lone pair of electrons, it can fulfill its octet configuration and then release H plus ion, So and also here hydrogens are there, but it can't able to release easily H plus ions from this OH group. Okay, these are not directly attached to the boron, these are attached towards the oxygen to the boron. So it is a weak Lewis acid and also monobasic. Why monobasic? Because it can able to accept lone pair of electrons from OH minus ion. If it reacts with water, then it will release one H plus ion, so that you can take second option here. Second option, it is monobasic and weak Lewis acid. This is the answer for this question. HbO3 while reacting with water, it can forms metaborate. Okay, it can forms metaborate. After reacting with this one, one compound will form, and that means another OH going to be attached here, this is the metaborate. Okay, previous one, this is the hydrogen borate, but here it is the metaborate. Okay, just remember. Then we will move to next question. If you check this question, which one of the following carbonyl compound exists enolization? Nothing but which of the carbonyl compound exhibit enolization? I want to tell you one thing here. For enolization, adjacent to the carbonyl carbon, alpha hydrogen needed. Nothing but next to the carbonyl carbon, alpha hydrogen must and should be there, so that you can directly check, is there any hydrogen present for all adjacent to the carbonyl carbon? You can check. See, this one here, double bond O, here there is no hydrogen, and here you can check, here one possibility is there. Here see, hydrogen. Okay, here one hydrogen is there, but that immediately double bond is there, so that if it is going to this one, not possible. Okay, again immediate double bond will be possible, so that is not comes under as a enolization. Here it is possible, and also here see, here two hydrogens also there, here also adjacent carbon atom have alpha hydrogen, nothing but hydrogen here, but here there is no hydrogen. This one is not possible, this one also not possible. So 2, 3, 4, which in which option you got? C, B. For exhibiting enolization, must and should be adjacent carbon of carbonyl possess hydrogen, then only it will going to be show enolization. Remember this one. Okay, then we will move to next question. Next question, you can see increasing order of dipole moment, for the following compounds. So first one, you can see, this is a methyl group on benzene, 2 chlorine atoms, metachlorobenzene, orthochlorobenzene, parachlorobenzene. Which one is having more dipole moment? Here you can see, here you will get first option. Fourth one is very less dipole moment, because 2 chlorine same energy containing atoms are nothing but chlorine atoms here attaches to the benzene ring in opposite direction, so that maximum almost all 0 for here. Next one, see, first molecule, that is methyl group attached to the resonance, only dipole moment happens only one side, not for both sides, because this is always donating group, this is donating group. So that benzene ring, because of resonance present in this benzene ring, it is always taking electrons towards itself. So this is comes next. And then second one you can see, chlorine atoms are attaches in meta position. Ortho position is more dipole moment when compared to the meta and para position. So first option you got. And second, next question you can see, in carbon dioxide molecule the hybridization of carbon and oxygen are respectively what? You need to identify here hybridization of these two atoms present in the CO molecule. You need to take first of all what is CO structure. By seeing carbon dioxide molecule structure, you can easily identify. For identification of hybridization, you have one formula, that is a number of pi bonds present around the central atom and number of lone pairs. Okay, so here if you see hybridization to identify carbon, two pi bonds are there, this is one and this is one, no lone pair, so that it is sp hybridization for carbon. For oxygen you can see one pi bond plus oxygen have two lone pairs, so that it is having sp2 hybridization. So carbon sp, oxygen sp2. So which option you got here? First option. Okay, this is about today's class. If you feel useful and informative, please do subscribe, share these videos to your known people, mention your words in comment box, don't forget to like. We will meet in the next class.